Okay, 9.1 day 2, we're going to use right triangle trigonometry to solve for missing values and then do some applications. This is just like you did in geometry. Okay, the first thing is I want to set up a trig equation. So I'm going to look at the triangle and see what I know. I know this angle. So from this angle, label, the x is on the opposite side. The 15 is on the adjacent side. So I want to write an equation using opposite and adjacent. Which equation uses opposite and adjacent? It should be tangent. So I'm going to write an equation for tangent. It's the tangent of the angle I used was 38 degrees. And then tangent is opposite over adjacent. Okay, now I need to solve for x. It says use a calculator to approximate to the nearest tenth. Sometimes it doesn't say to use a calculator, so I'm going to write it in exact form and not. So I'm going to times by 15. Okay, now if it said to leave it as in exact form, I would actually leave it as 15 tangent 38 degrees. That's considered an exact answer. But since it tells me to use a calculator to approximate to the nearest tenth, I'm going to do an approximate answer. So in my calculator, I'm going to do 15 tangent 38. If you're on your phone, you're going to have to do 38 tangent times 15. And then my answer is about 11 point, it says tenth, so that's one decimal, so about 11.7. Okay, and your answer should look realistic. This side does look shorter than this side, so 11.7 seems realistic. Okay, let's look at B. B says to find n. Okay, again, start with what you're given. I'm given this angle, so I might as well use it. Okay, the two sides that are marked are this one and this one. So what is 58? 58 is definitely the hypotenuse side. And then n is on the adjacent side. So I want to use the trig function that uses adjacent and hypotenuse. That's going to be cosine. So the cosine of 41 degrees is adjacent over hypotenuse. Okay, now we're going to solve for n. So n over 50, I'm going to multiply by 58. Okay, and again, I'm going to write it in exact form, even though it doesn't ask for it, just so you know. The 58's cancel out, so n equals 58 times the cosine of 41 degrees. And this is the exact answer, but they want me to round it. So in my calculator, I'm going to do 58 times the cosine of 41. If you're on a scientific calculator, you could probably type the whole thing. If you're on your phone, you got to do it step by step. Okay, it says 0.77, so I'm going to round it to 0.8 because it said to the nearest tenth. Okay, one more like this. It says find P, and there should be a right angle on all of these. So again, I'm going to start with what I'm given. I'm given the angle 71. So 24 is opposite. P is on the hypotenuse side. So the trig function involving opposite and hypotenuse is sine. The sine of 71 degrees equals opposite over hypotenuse. Okay, now I set it up correctly, but it is a little weird when the numbers on the top. So there's a couple ways to solve it. You could cross multiply or you could multiply by the P. Both ways are going to give you the same answer. I'm going to times by P, but I'll show you the cross multiplying to show you the same. Okay, it's weird to solve by P because it doesn't get better. So I'm going to get P times the sine of 71 degrees equals 24. Okay, if you cross multiply, then you put this over 1, and I do P times sine 71 equals this, and 24 times 1 is 24, and I get the same. And again, I know this doesn't look good, but to get the P, I'm going to divide by sine of 71, and the sine of 71 degrees can never be separated. One cannot live without the other. Okay, so my exact answer is 24 divided by the sine of 71 degrees. But since it asked me to do a decimal, I'm going to put in my calculator 24 divided by the sine of 71 degrees. I got 25.38, which I'm going to round to 25.4. Okay, and then I am going to look at the picture just to make sure it makes sense. If this is 24, this could be 25.4. It is a little longer. The pictures aren't always exactly exact, but they should look reasonable. Okay, let's look at example 2. Example 2 says solve triangle ABC with the given measurements. Okay, when it says to solve, what it actually means is find all angles and sides. Okay, so let's see what we're given first. So the first fact they tell me is that A is 20 degrees. Since it's degrees, that's the angle. So I already know the angle 20. Angle A is 20 degrees. I know that this is a right angle, which is 90 degrees. What else do I know? I know that C is 13. So let's go ahead and put little c as 13. I know it's not the angle because it doesn't have degrees. Okay, let's find angle B first. Okay, what does the angles of a triangle add up to? They add up to 180. Because if I want angle B, I'm going to do 180 degrees and I'm going to minus the 20 degrees for angle A and I'm going to minus the 90 degrees for angle C. So 180 minus 110 is 70 degrees. Okay, so now I know that this is 70 degrees. So I'm done. I found all the angles. I still need to find the sides. I know C is 13. I still need A and I still need B. And it doesn't matter which one you do first. I'll just do A because it's there. Okay, now I have both angles, so it doesn't matter which one I start from. You just need to pick one and go with it. If you do it differently, we're going to get the same answer. So I'm going to start from angle A. From angle A is the opposite side. And then the only other side I know is the 13, which is the hypotenuse side. So I'm going to do, what do I have? Opposite and hypotenuse? That's sine. So I'm going to do the sine of 20 degrees equals opposite over hypotenuse. Okay, I'm going to times 13 on both sides. So A is 13 sine 20 degrees. It doesn't tell me to round it, but we're going to go ahead and round it. So I got about 4.4. So A is about 4.4. Does that look realistic? Yeah, if this is 13, this could be 4.4. Okay, so now I have this side and this side. No, this side and this side, I still need B. Okay, now there's a couple ways you could get B. I could do another trig function with B, or I could use Pythagorean theorem with B. Both ways, I will get the same answer. So if you prefer trig, I would probably do the cosine of 20 as b over 13 and solve it that way. If you prefer Pythagorean theorem, then you would do Pythagorean theorem. I'm going to do Pythagorean theorem just to show you. So if I do Pythagorean theorem, it's going to be a squared plus b squared equals 13 squared. Okay, and we're going to have to use our calculator. So 19.36 plus b squared equals 169. I'm going to minus the 19.36. B squared is 149.64, and I'll square root it. Okay, so I got about 12.2, and then just glance, make sure it's reasonable. The picture's not accurate, but this could be 12.2. The hypotenuse is longer, it's 13. Now, if you look at this amount of work, and this looks fine, this is a good way to do it. But again, I could have done cosine of 20 is b over 13 and got the same exact answer. So whichever method you prefer is fine. Okay, let's solve one more triangle. And again, if you do your work differently, that's fine. We should end up with the same answers at the end. So what do I got? Angle B is 61 degrees. So let me go ahead and get the missing angle then, because I know it adds up to 180. So what am I missing? Angle A is going to be 180 degrees minus 90 degrees minus 61 degrees. I can do that really quickly with my calculator. Okay, so I got 29 degrees for this angle. Okay, now what side? They gave me A is 5. So I know this side right here. Okay, now whether you want to get B or C first is totally up to you. Okay, so let's see. What should we do? Now, they gave us angle 61, but I also know angle 21. So you could do either angle as well, and your work could be different. We'll get the same answer. What do I think? I think I'm going to use angle B just because they gave it to me. Should we do B or C first? Doesn't really matter. Let's do B. So from B, B is the opposite. What is A? A is the adjacent. So one way to do this is to do OA, tangent equals opposite over adjacent. What else could I have done? I could have done the cosine of 61 is 5 over C. I could have done the tangent of 29 is 5 over B. I could have done the sine of 29 is 5 over C. All of these are going to give me the same answer. So if your work is different than someone else's, that's fine, but go ahead and check your actual answer with them to make sure that you're getting them right. And just look to make sure your answer looks reasonable. So let me do 5 times the tangent of 61, and I got 9.0. That seems okay. A is 5, B is bigger. Okay, what are we missing? We need C. Okay, and I used Pythagorean theorem last time, and I can still use Pythagorean theorem. It'd be 5 squared plus 9 squared equals C squared. I think I'll do trig this time just to do differently. Let's see. So from 61, say I use 5 and C. What is that? Adjacent hypotenuse, that would be cosine. Equals adjacent over hypotenuse. Oh, it's that weird upside down one. Let me times by C, even though it looks weird. C times the cosine of 61 degrees equals 5. Divide by cosine 61 degrees. So C equals 5 divided by the cosine of 61 degrees, which is 10.3. Okay, and then does that look right? That does look right because the hypotenuse should be longest and 10.3 is the longest. Okay, and again, if you use a different method, we should get the same answers. Okay, last thing is applications. We're going to sketch and label a picture, then we're going to use right-angle trigonometry to find the indicated value. Okay, it says an 18-foot ladder is leaning against a vertical wall. Okay, this is going to be my wall. We're trying to get a triangle, so your stuff doesn't have to look like what it is. That's my wall. 18-foot ladder. Okay, my 18-foot ladder is going to be right here. I'm going to make it look like a ladder. Oh, I'm going to try. You don't have to. Okay, that's my 18-foot ladder. The ladder makes a 64-degree angle of elevation. Okay, angle of elevation is always from the ground. So it's always going to be coming from the ground. So if it's coming from the ground, it's got to be here. It couldn't be this one because that looks like a right angle because your wall should be at a right angle, which is good because this looks like a triangle. Okay, we're trying to find out how high up the wall is the top of the ladder. So the top of the ladder is here. This is the wall. So how high up the wall? We're trying to figure out this value right here. Let's call it y. Okay, as long as you get a triangle. So I know this is 64. The y is the opposite. The 18 is the hypotenuse. So let's opposite hypotenuse, sine. Opposite hypotenuse. Okay, I'm going to times by 18. And then I'm going to go ahead and put it in my calculator. And I'm going to just make sure it seems reasonable. Okay, I got 16.17, so I'm going to make it 16.2. That does look reasonable. The ladder's 18, so it should be smaller than 18. Let's try one more. Okay, a hot air balloon is descending toward a landing field. The angle of depression, okay, the first thing I'm going to tell you, depression is depressed. It starts out here and it goes down. So an angle depression is always coming from the ceiling. Elevation from the ground up, depression from the ceiling down. Okay, a hot air balloon is descending toward a landing field. The angle of depression for the balloon is 18. The altitude of the balloon is 100 meters. Okay, let's try this. Okay, here's my hot air balloon. You don't have to draw a balloon. Here, I'm going to draw a balloon. Oh, that doesn't look like a balloon. That's why you should not draw a balloon, because yours might look terrible like mine. Okay, the angle of depression is 18. Depression comes from the ceiling. So this angle has got to come from the ceiling. And I don't care if it's to scale. I care that I get the triangle. Okay, the altitude of the balloon is 100 meters. So this is 100 meters. My triangle's all discombobulated. What's the distance from the balloon to the landing field? Okay, let's finish off some triangles here. Let me make this a triangle. Okay, and then I'll go ahead and finish this off because I need this. And then what's the question asking? What's the distance from the balloon to the landing field? So I think we're going to try to find this distance here. Okay, so I need a triangle. I have two. Which one should we use? I think I'm going to use the green one. The 100's over here, but if this is 100, this has got to match. So this is going to be 100 over here. Okay, so now let's see what we have. Okay, I know this angle is 18. What do we have? 100 is opposite. D is hypotenuse. Opposite hypotenuse. What is that sign? Sine of 18 degrees equals opposite over hypotenuse. Okay, it's a weird one with the letter at the bottom. You can cross multiply. I normally multiply by the bottom. D times sine of 18 degrees equals 100. I'm going to divide by sine 18. The sine and the 18 are stuck together. They do not exist without each other. Okay, so D is going to be 100 divided by the sine of 18 degrees, which is 323.6. Okay, let's look at the picture. This is 100, 320. I mean, it could be 323.6. It's not really drawn to scale.